Hello. Excuse me. Hello, everybody. How are we this evening? A bit earlier than usual. Things are going to be changing, I think, with this current setup. It kind of looked like my door was open. Doesn't it kind of look like that? It's not, though. Because that job that I mentioned yesterday, I'm very nocturnal right now, which lends itself to streaming at night. But yeah, with the new job, like I'm not going to be able to be as nocturnal as I am right now, and so I might be streaming more late afternoon, like after work, sort of thing. We'll see. I'm going to try and get enough freelance work so that I don't need that job. We'll see. We'll see what happens with that. May the Lord's will be done. But enough lollygagging. We are going to get into web services, service-oriented approach. This might be a short one. We're only going to do this one, even if it's a short one tonight. I had talking about getting freelance work. There's a big editing project that I want to get a good amount of work done on. Done on, I guess, tonight. And so, I want to get this done so I can get some of that done, and then also a buddy of mine and I are going to be, just jamming on some video games later. So it's not entirely productive. I need to hold on a second. Okay. Yeah. Sorry, that was my buddy just texted me. So let's get into this.
So the service-oriented approach is a way we approach solving a complex application problem where all the data really isn't present in one computer system.
Hold on.
So the service-oriented approach is a way we approach solving a complex application problem where all the data really isn't present in one computer system. It's somehow spread out over the internet, connected via the internet or internal network. And so the idea is that...
Okay, service-oriented approach. Most non-trivial web applications use services. They use services from other applications. Credit card charge, hotel reservation systems. Services publish the rules applications must follow to make use of their service API. Oh. So service. Application APIs are like the rules. Okay.
Some applications just can't contain everything. The perfect example is a travel website that can book you a flight, book you a car, buy tickets, book you a hotel, and do all these things. Well, that travel website is neither a hotel nor a rental car company nor an airline. But what it really does is it talks to all these services somewhere else on the web on your behalf, and it makes reservations for you. And so you have this convenient user interface that says, oh, here's your whole vacation. I'm going to figure all this stuff out. Now you say go, and it goes book, and books on all these other systems. Now it requires a lot of infrastructure, a lot of coordination, and a lot of effort to make sure that your application can talk, and these other services that are out there in the internet, infrastructure, a lot of coordination, and a lot of effort to make sure that your application can talk, and these other services that are out there in the internet have good contracts, and you know exactly how to send data to them and get data back from them. And so initially,
multiple systems. Initially, two systems cooperate and split the problem. As the data service becomes useful, multiple applications want to use the information. As the data service becomes useful, multiple applications want to use the information application. That makes sense.
When you're building a service-oriented architecture, often you have one application and it's all internal. Often it's all one language, and then maybe you'll say, oh, wait a sec, we want to take part of what we do and put it in a second system, and then sort of come up with a set of rules between the systems, and then more and more and more. And this is a video that talks a little bit about the process and complexity rules between the systems, and put it in a second system, and then sort of come up with a set of rules, all one language, and then maybe you'll say, oh, wait a sec, we want to take part of what we do and put it in a second system, and then sort of come up with a set of rules between the systems, and then more and more and more. And this is a video that talks a little bit about the process and complexity about taking these interfaces between applications and applying standards to those interfaces.
Wait, that's it? That's it?
Interfaces between applications and applying standards to the process and complexity of it talks a little bit about the process and complexity about taking these interfaces between applications and applying standards to those interfaces.
Okay. If we were to look that up, what would we find? Hold on a second. Okay. I suppose I didn't need to go to YouTube, huh? Equals edge. I don't know why he put the link in there. We can't like click on the link. Oh, well there we go. So maybe we'll watch, you know what? Let's try and watch this, huh? We'll just watch
The service-oriented approach to linking software systems and applications is transforming the way many organizations share data. This approach improves existing methods of data sharing by providing a service layer between systems. Sharing data between applications is a well-established principle that works on a simple level. As systems expand, the solution that connects two software applications will often not work for a third. What began as a workable system then logs valuable data in a silo. Sharing the data is still possible, but requires adaptations and tweaks. The process is laborious and time-consuming, leading to bottlenecks and overload. The reality of this world is unnecessary effort expended in duplication of data. By applying a service layer to the applications you wish to connect up, data is offered up in a common format for reuse elsewhere. The service-oriented approach works with existing software systems and does not require you to remove the monolithic application. Replacement applications reuse the links already made and can plug into the service layer without affecting other users of the data. New applications can be added to grow overall system architectures in the same way. The data in each application is offered up as a service which any other application can consume. When the service-oriented approach is evolved into a system-wide architecture, it allows connections and service sharing opportunities between organizations nationally and globally.
I get that.
Take monitoring of student progress, for example. Results are logged by a virtual learning environment, but how much of that data is shared with a management system that is tracking progression against funding? If the motivation and commitment of struggling students is not addressed and they decide to walk away, there is a direct impact on funding. If the data is freed up and shared across a system using a service-oriented approach, it could contribute to retaining student motivation and thereby maximizing income. And what if across the education community there was one standard and agreed way to describe a course? It would allow course information to be made available as a consumable service both internally and externally. This is the subject of a current project called Exchanging Course-Related Information, or XCRI, encompassing course marketing, quality assurance, enrollment and reporting requirements. This service-oriented approach enables aggregator organizations like UCAS to gather the standard and agreed descriptions of courses from each provider. Comprehensive details of approved enrollment opportunities are then returned to a prospective student for easy and accurate comparison. Amongst the research community, it is the same principle. Here, the service-oriented approach is enabling researchers to work across institutions in virtual organizations. MyGrid is a project that provides a shared toolkit for creating experiments by coordinating the information flow between distributed resource institutions in virtual organizations. MyGrid is a project that provides a shared toolkit for creating experiments by coordinating the information flow between distributed resources and services. Workflows and query specifications link together remote and local resources using web service protocols. Workflows created by MyGrid represent the scientific process of the experiments they enact, making them a rich resource for scientists creating their own new experiments. The service layer to this data enables users to share, reuse and repurpose experiments within the MyGrid community. Institutions in virtual organizations. MyGrid is a project that provides a shared toolkit for creating experiments by coordinating the information flow between distributed resources and services. Workflows and query specifications link together remote and local resources using web service protocols. Workflows created by MyGrid represent the scientific process of the experiments they enact, making them a rich resource for scientists creating their own new experiments. The service layer to this data enables users to share, reuse and repurpose experiments within the MyGrid community. Many education and research services are already developing a service-oriented approach, taking their lead from the business world and major software developers. It is in this context that the E-Framework, a successful and expanding international initiative, works to make sense of the service-oriented approach for the education and research community. The E-Framework website identifies and describes the service components needed. It provides the blueprints and reference examples for those in the community who want to gain a greater understanding and knowledge of how to implement a service-oriented approach. The E-Framework website is thus becoming a research community. Works to make sense of the service-oriented approach. Successful and expanding international initiative works to make sense of the service-oriented approach for the education and research community. The E-Framework website and major software developers. It is in this context that the E-Framework, a successful and expanding international initiative, works to make sense of the service-oriented approach for the education and research community. The E-Framework website identifies and describes the service components needed. It provides the blueprints and reference examples for those in the community who want to gain a greater understanding and knowledge of how to implement a service-oriented approach. The E-Framework website is thus becoming a knowledge base that is developing a shared vocabulary and way of thinking for all in education and research.
Okay. Cool. All right, that was actually a pretty good video. Okay, what the services-oriented approach to developing web apps. Where is the data located? Spread across many computers, systems, connected via the internet or internal network. Boom. 71%. We're getting there, man. Man, I'm kind of nervous because it's like once we finish this, I kind of feel like that's when the rubber meets the road, you know? Gotta take the training wheels off. Like I wanna start like trying to make stuff. And then eventually we're on to the next course for the next thing, but it's like with Python, because I think I've heard it said you can get jobs with just Python. You know what I mean? By just knowing Python. And I'm like, what? Oh, we're getting into APIs? Okay, great. I'm excited for this. I'm pretty excited for this. That's going to do it for today, though. I'm afraid. What are we at here? 16. Yeah, pretty short. This might be our shortest stream. But we're going to call it there. Thank you guys so much for watching. Tomorrow is Friday. Well, technically today's Friday, but tomorrow, Friday. We'll stream tomorrow night, and then I'll be off the weekend, and I will be back the following week. But again, thank you guys so much for watching. Please like and subscribe if you enjoy this sort of content. If you enjoyed the video, please comment below if you have a prayer request. I'd love to know how I can be praying for you guys. But love God, love people, and I will see you guys soon.